ஓகே. இப்ப நம்ம ஹேஷிங் பார்க்க போறோம். ஆ ஆக்சுவலி ஓகே. ஆ highest occurring element in an array. இப்போ கொஷின்ல படிக்கிறதுக்கு டைம் 3, 2, 1 ஸ்டார்ட். Given an array nums of n integers, find the most frequent element in it. That is the element that occurs the maximum number of times. If there are multiple elements that appear a maximum number, find the smallest of them. Okay. This section will be a bit difficult without prior knowledge on what hashing is. We will soon try to add basic knowledge. So they have given an array of integers. We need to find the maximum. If there are more than one maximum occurring numbers. That is, if the frequency of occurrence of the maximum numbers, another number also has the same frequency of occurrence as the max number, then we need to take the smallest of the two. So, what does this have to do with hashing? Um, what's hashing? So, we can put the occurrence of the number and uh, the number and its frequency as key and uh, value in hash map. So we have this one and we are putting frequency as key and element values. So uh, after putting that, for that we need to use a for loop, and then what we have to do, now we have all the information we need. Uh, so now we just have to find what is the greatest value in the hash map, and the corresponding key of the greatest value is the answer. If two thing has same value, then uh, then it will, we have to find another, put another logic to find this. So, but how to find the greatest element in hash map? For me, we are okay. So okay, in this for loop, what we will do? In this for loop, what we will do is that um, let's say there is an array. First element we are seeing, then I is equal to 0. Uh, no, if we have array, we can use enhanced for loop. So, so okay, let's say I is equal to first element. Then, then what we have to do? If that element equals, come, we have some methods here. So we will see if this element is available there or not. For that, we have a function in hash map. Let's see. Method, sorry. What method we have? Contains key. Contains, okay. Uh, Put if absent. Write an entry into the map if only if an entry with the same key does not already exist. So we will use put if absent. Okay, I'll write the full syntax for it. So Notice the array. So we will do map dot. Let's say we have some numbers here. Put if absent uh, what we have to put value. Put if absent means so put if absent means it is putting for the first time. So the value is default 1. So the key will be the I and the value will be 1. Okay, this is the first time. And then if that is not the case, then a W3 school is waste. Um, Key set values entry set. Mhm. Waste. Compute if absent. Compute if present. Okay. So compute if present ஒன்னு இருக்கு. So அதை நம்ம we can use that one. Update the value of a specific key only if the key already exists in the map. So if doesn't exist, it will put 1. But we are already okay. Uh, this will also be good. Updates the value of a specific key only if the key already exists in the map and is not mapped to null. Okay. So map dot compute if present. I mean, we don't actually need this because we are already checking that it is absent or not. So if it is not absent means, uh, wait, if this is happening, we don't have to write this. So first, we will put an, wait 1 second. compute if absent. Okay, maybe we can put uh, okay, we can do that. Can put an if statement, and if it does not contain a key, so not operator map dot contains key, which means if it does not exist, then map dot put if absent I comma 1. Else, if it exists, then what we have to do is that we have to update it by update its value. So put so we can do put method. So map dot put I comma. Now we have to update it to 1 extra. So what we have to do is we have to do um, uh, okay. Now we can uh, okay, map dot put inside bracket I comma map dot get inside bracket I, and then outside plus 1 close bracket. So here it will increase the existing value of the key I and store it into it. Okay, now our hash map is ready. Now what we have to do? நான் வேணாம். இப்பதானே கான்ஃபிளெக்ஸ் சாப்பிட்டேன். நான் வேணாம் உனக்கு. ஏய், இப்பதான் கான்ஃபிளெக்ஸ் சாப்பிட்டேன். கான்ஃபிளெக்ஸ். இப்பதான் சாப்பிட்டேன் போ. So, so our hash map is ready now. Now we have to take the highest element. So what method we can use? for each contains key. Implicit. Okay, so I think we have no other way. We have to use another for loop to find the maximum element. Hmm, but I am thinking that we can uh, find the largest value inside this for loop itself. Um, I think here what we can do is now we can do outside this if else map dot get I we can store this in some other variable. Let's say a sorry mm, int a is equal to map dot get I. Now um, now what we can do? Oh no. Before that we have to do one. This should be inside if map dot get I is greater than or equal to a, then int a is equal to map dot get I, and then so uh, and then int d is equal to we have to store the key also. I but the disadvantage of this method probably will be if more than one key has same value, then we don't know how much what we don't know how much key has same value. Maybe what if all the key has same value? Like 2 2 3 3 4 4 5 5 is the array. Then the answer would be, I mean, everything has then all the key will have same value. Then in this key, we have to store all the things. In this variable, we are storing key. So if more than one key is there, then we need to introduce more variables to store all the keys. But what we can do is we can first store one thing and then we can uh, initialize this to zero. That is one thing, but still uh, okay. And then uh, I think we can put no. Okay, we need only the smallest thing. No, so we can use stand operator and no. Wait. We have many different cases. So if map.get I is greater than a, then no doubt we can put int a is equal to map.get I, int b is equal to I. But else if map.get I is equal to a, but sorry, and the key is less than the key of the previous stored thing. So I is less than b. Then what we can use, uh, then also we will do the same thing. Yeah, okay, it's fine. In these both condition, you will do the same thing. Int a is equal to map dot get I. Int b is equal to I. So we have a form. So in this, okay, let's do it with an example. Let's say we have one, two, one, two, three. Now in this we have one, not map dot contains. What is it? Map dot what is contains I. So is it there? No. Then it is false. Sorry, it is false. Then not means it is true. So if it is not there, then it is true. So map output is absent. So one comma one, and okay, skip else. And then map, we should initiate these values. No, we don't have to initiate these values. Fine, whatever. If map dot get I, okay, one is okay. We need to initiate this. Uh, but they can be negative also. No. Your map A cannot be negative. A can be up to zero. So int A equal to zero. And then D we need to put the least number in the integer. Yeah, fine. Okay, let's see. So map dot get I. is equal to, no, we can put B as the first number. Okay. In B is equal to array, or first number of the array. That is fine. Map dot get I is greater than A. So A is 0. Map dot get I is 1. So A will be what? A will be 1. B will be 1. Now go to the next one. Does does map contains 2? No. Then it is true. Then you should put 2 comma 1. 2 comma 1. Now we need to see if map dot get I, or is that get the value of I is not 1, is greater than A? No. Go to the other one. Now is equal to A? Yes. Is I is what 2 is less than B? No, B is equal to 1, I is equal to 2. So this is false. So this will go to the next one. And then you have 1. Map that contains 1? Yes. 2. If not means false. So else equal to. So map dot put I is what? 1. Map dot get is already 1, 2. So B value will be sorry. This value will be 2. And here, what will happen? Map dot get I. What is that? 2. So 2 is greater than 1? Yes. So it will change its value to 2. And then B is equal to I is same 1. Then it is this. And then 2. 2 map dot conventional put, and then it will convert it to 2. And then it will check if 2 is greater than 2. No. And then here map dot get 2 is equal to 2. But 2 is not smaller than 1. So this will skip. And then we have 3. 3 does not contain. So you will have, it does not contain 3. So you will have 3, 1, and then in the central network. Okay. So, so I think now we have the answer. I think, so now, wait 1 second. If map that data is greater than, okay. So I think this will work. Let's try it in code. Okay. So maybe I can share my screen if possible. Okay, I think you can see my screen. Okay. So now, uh, So we have nums. We need to create a hash map first. First, how to create a hash map? Hash map key integers, no? Integers name hm is equal to new. Okay, so mm, okay, now we can create a hash map with the size of array. So we have to create the hash map in the capacity. We have to make it int. What is the capacity of hash map? Nums dot size or length property. Okay, length. Okay, that will be the another thing. We have only 3 minutes. It is fine. Now, uh, so for loop, enhanced for loop for int item. I is enough. I for int I what nums uh, what we have to do is here int frequency uh, max max equal to nums 0 and then int fre- frequency is equal to, let's say, 0 for first, and then if not. Okay, not operator is okay, fine then. Not hm dot contains I, then hm dot put if absent I comma 1 and then else hm dot put I comma hm dot get I plus 1. So I think time is 1 minute we have. Okay. And then we can put another funds. If hm dot get I is greater than a, sorry, now what is a frequency? Frequency, then frequency is equal to hm dot get I and max is equal to I. Else if else if hm dot get I is equal to what is the frequency and operator. What's and operator? And means and okay. So shit. And I is less than max. Then we should use frequency is equal to max dot get I and then max is equal to I. Okay, I think it's over. Probably the time is also over, but still. Uh, okay, so okay, let's believe that this code is fine, and then let's return what we have to return max. RETURN max. Uh, as expected, there is a lot of error. Okay. Hash map is not declared in this scope. What does that mean? Oh shit. Oh shit. The whole thing we have done in C++. Let's copy this. Okay. Now probably it will be good. Let's see. Another error. Where? What happened? Oh. put if gap I have given. Okay. And then put if absent. Put if absent factory. Okay, let's try. Hash map. Cannot find a symbol hash map. Cannot find a simple integers. Not happening. Cannot find a simple integers. Cannot find map.get. When did map.get? Oh shit. hm.get. Okay. Okay. Cannot find a symbol. Let's put. Cannot find symbol. Okay. Import java util.hashmap. Wow. Correct. Cannot find symbol. Except man. Oh shit. It should be outside for loop. I think this. Cannot find symbol means what? Oh shit. Hash map. Oh, integers. I added. Oh, silly mistakes. What hm dot contain? What is oh contains hm dot contains key. Okay, contains key. So much mistake. Only done 9 attempts. Oh, accepted. Wow. Okay, so we have done this, but let's see whether this is the optimal solution or not. Okay, try now. Upgrade to submit. So we cannot submit now. Fine, no problem. See the solution and explain why your solution is wrong. Not well. Take notes on learning. Okay, I will take notes. Let's see the solution. Java code. Okay, what they have done is created a hash map and then hm.put get. Oh, they have used this one. Okay, we have used if else statement. They have we have put this much long for that, but they have did only this one. But what is the optimal solution? Hashing brute force approach. Make a visited array of type boolean. Use the first loop to print point to an element of the array. Initialize the variable to confirmation. I don't understand. Frequency counter. No, it is not frequency counter. Sorry. Highest occurring element. Optimal approach. Take an unordered hash map of pair. Use a for loop to iterate the array. If the element is not permanent, insert it with frequency, otherwise increase the existing frequency by 1. After visiting the whole array, we will find the element with the highest frequency and the element with the lowest frequency by iterating the map. Okay, iterate. So we have to iterate both times. Wait once again. Here, map integer. Okay. Uh, so we have used only one for loop to store everything. And then int max frequency is equal to 0. Min frequency is equal to n. Max time complexity is space complexity is also very high. Okay, min frequency n max frequency. Traverse map to find min and max. So they have created an array. We have created, they stored everything in a map and then map.entry, integer entry, map.entry set, int element is equal to entry dot get key, int count is equal to entry dot get value. If count is greater than max frequency, max frequency is equal to count, max element is equal to element. If count is less than min frequency, Wait, let's ask ChatGPT which is the optimal solution. I think my solution is better because they are using two, like, I think they are using two for loops. And also, if both numbers are high, okay, let's see. Okay, first let's give their solution. Oh shit. Let's give my solution to ChatGPT. Both solutions have the same time complexity or else. So the driver's optimal solution first builds a frequency map and then they traverse the map again to find the maximum frequency. In my approach, while building the hash map, we at the same time we find that we keep track of the highest frequency. For how much time we have? 13 minutes. Okay. Okay. Turns out my approach is slightly better than them, but still, I hit. Maybe my approach may have slight edge cases, but I don't know. Let's see. Okay, so I think I have made the optimal solution now itself, but this is using hash map. Okay. Okay. Now I don't think there is anything to take notes from this thing, but I think I need to say the brute force also. Method to count frequency and find elements with its maximum frequency. So, no, I think brute force I can do it with myself. Brute force, highest element, I have already done, I think. Okay, then let's take 5 minutes rest. Sorry, 10 minutes. Let's take 10 minutes rest. Bye bye. Daddy! ஓகே. இப்ப நம்ப வந்து ஆ மெர்ஜ் சார்ட்டிங் அல்காரிதம நம்ப கத்துக்க போறோம். அதுக்கப்புறம் அதோட கோடையும் வந்து இம்ப்ளிமெண்ட் பண்ண போறோம். இப்போ என்ன பண்ணலாம்னா, ஆ 1 செகண்ட். ஓ ஷிட்! வெயிட், நான் லாகின் பண்ணிட்டு உங்களுக்கு இத காமிக்கிறேன். இப்ப காமிக்க முடியாது. லீட் கோட்ல சேம் கொஸ்டின் நம்ம போட்டு பார்க்கலாம். லீட் கோட்ல சேம் கொஸ்டின் நம்ம போட்டு பார்க்கலாம். ஓகே. இப்போ கேஸ் 1 output is 1 nums. இந்த கொஸ்டின் கொஞ்சம் கஷ்டமா தான் இருக்கு. இவங்க வந்து ஆப்பரேஷன்ஸ்னா இட்டரேஷன்ஸ்னு சொல்றாங்க. ஸோ கே இட்டரேஷன்ஸ் பண்ணிட்டு நம்மளுக்கு மேக்ஸிமம் பாசிபிள் இது என்ன வருது? இப்போ 5னா 2 வந்து 3, 4 2 ஆப்பரேஷன். 1 வந்து 1, 2, 3 4, 4, 4ன்னு வருது. ஓகே, இதை நம்ம போடலாம். ஆனா இப்போ நம்மளுடைய aim இது கிடையாது. அப்புறமா போடலாம். இப்போ சார்ட்டிங். ஓகே, எப்படி அடுக்கி வைக்கிறது? நான் இதை காமிக்கலாம். சாரி, ஓகே. கோட் பண்ணும்போது மட்டும் உங்களுக்கு இதை காமிச்சா போதும். தெரியுதுன்னு நினைக்கிறேன். ஓகே, இப்போ given an array of integer nums, sort the array in non-decreasing order using the selection sort algorithm and return the sorted array. Okay. So, selection sort means first we have to choose first element in the array. If we have to make it at the increasing order, then we have to choose first element and then we have to choose the once again last element. We have to choose the largest element. Shit. Wait, I have to see the video again. Sorting.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this will be another lecture from the Scribers A to Z DSA course. Just in case you're for the first time here, this course is India's most in-depth course on DS Algo. Why do I say that? The course has 456 modules. You can go to the market, buy any of the paid courses, check out any of the free courses. None of those courses on DS Algo will have 456 problems or modules solved. So this is definitely by far one of the most comprehensive course on DS Algo, and this is the only thing that you will be requiring if you are preparing for placements. So in the previous videos we have covered the step 1, and now we will be going to step 2. Now the step 2 states you have to learn important sorting techniques. In order to start your journey with DS Algo, sorting is something which you have to know. Even if you're going for placements, they might ask you sorting algorithms. And the sorting one, which is step 2.1, we have three algorithms: selection sort, bubble sort, insertion sort. So if you are appearing for placements, they might ask you, hey, can you please tell me the code for insertion sort? And you have to tell them, right? And sorting 2 will be based on recursion. So we'll be covering that in the next lecture. So without waiting, let's start with selection sort. So before moving ahead in the video, let me tell you about LearnBase. So LearnBase is an edtech platform that offers you data science and full stack development programs in one to watch and learn. So when our team checks the minimum, and you will say, who is the minimum? And what selection is selection sort. As the name recommends, selection. What do you select? We select minimums. Remember this. As the name recommends, what do you select? We select minimums. So as the name recommends, select minimums. So what you will do is, you look at the entire array and you will say, who is the minimum? And it states 9 is the minimum. So you'll take that 9 and you'll place it here. Perfect. I place the 9 here. And if this 9 is the minimum and you're placing it at the first place, where will 13 go? 13 says, okay, no issues. I will go to your place because 9 has to come at first. And now I'll write the remaining guys over here. That's how you do it. So that is the step 1 of the algorithm. Step.
ஓகே. ஹாஃப் அன் ஹவர்ல நான் இத இம்ப்ளிமெண்ட் பண்ணிடுவேன். ஏன்னா ஹாஃப் அன் ஹவர் சொல்ல ஓகே, ஹாஃப் அன் ஹவர் ட்ரை பண்ணி பாருங்க. பிகாஸ் இஸ் நாட் லீக் கொடுத்துருவாங்க. ஓகே. ஸோ இது பாத்தீங்கன்னா உங்களுக்கு தெரியும். ஹவர் கிளாஸ். இது எங்கேயாச்சும் இங்க வச்சா நல்லா இருக்கும். So we need what we have to do is wait, I don't think there is anything to explain in the board because we are just implementing. The concept is already taught in the videos. So if that is the case, then I can present the windows. Okay. Okay. So now first we have to find the smallest element in the array and then swap that with the first element. What to do? But to find the smallest element in the array, we have to look to the whole array. Okay, let's try. So we have to loop through the whole array, find the smallest element, make it the first element, and the first element, make it the put it in the place of the smallest element, and then ignore the first element. Okay. Hmm. Okay. Okay. So now, okay. So now, okay. We have to make a so now, okay. So first we have an array least element. Okay. First let's we have
find
to make
first
a let's see how to find the least. So now smallest element in the array. So okay. We will have a pointer. So that first will we have an through array each least element. Okay. First let's we have
find
to make
first
a
let's see
we
how to
will
find the least.
so now smallest element
Compare
in the array. So okay. We will
every
have a
element.
pointer and we will store the least element. Okay,
So
let's that
first
will
for
we have an
through
array
I think from now
least
onwards I
element.
will only
Okay.
use
First
enhanced
let's
for loop
we have
find
to make a
because it
let's
is
see how
very
to
good
find the least. So now smallest element
compare.
in the array.
It's very easy.
So okay. We will
Every
have
at
a
first
pointer
I hated
and we will store the
enhanced
least
for
element.
loop,
Okay,
but
let's
that
that
is
will
very easy.
for we have an
Through
array
I think from now
least
onwards I
element.
will only
Okay.
use
First
enhanced
let's
for loop
we have
find
to make a
because it
let's
is
see how
very
to find
good.
the least. So now smallest element
Compare.
in the array.
It's very easy.
So okay. We will
Every
have
at
a
first I
pointer
hated
and we will store the
enhanced
least
for
element.
loop,
Okay,
but
let's
that
that
is
will
very easy.
for we have an
Through
array
I think from now
least
onwards I
element.
will only
Okay.
use
First
enhanced
let's
for loop
we have
find
to make a
because it
let's
is
see how
very
to
good.
find the least. So now smallest element
Compare.
in the array.
It's very easy.
So okay. We will
Every
have
at
a
first I
pointer
hated
and we will store the
enhanced
least
for
element.
loop,
Okay,
but
let's
that
that
is
will
very easy.
for we have an
Through
array
I think from now
least
onwards I
element.
will
Okay.
only use
First
enhanced
let's
for loop
We have to make first. Let's see how to find the layers. So now compare okay. We will every element I hated in to the list. So what can we for we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to compare. Make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to compare. Make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to compare. Make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to compare. Make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to compare. Make first. Let's see how to find the layers. So now compare that for initial. Okay. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to compare. Make first. Let's see how to find the layers. So now compare that for initial. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's for loop. We have to compare. Make first. Let's see how to find the layers. So now compare that for initial. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's we have to compare. Make first. Let's see how to find the layers. So compare that for initial. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. Let's we have to compare. Make first. Let's see how to find the layers. So compare that for initial. We will every element I hated in to the list. So what can we for then we have an through first element. I think from now onwards I will only use first. We have to compare. Make first. Let's see how to find the layers. So compare that for initial. We will every element I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find if I is smaller than smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So what can more than through first element. I think from now by this method we will try to find. Now we have find the smallest smallest now, now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the simple. So the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the I think they need the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the I think they need the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that now if just do that for initially. If I is smaller than num, we will bring first I hate the I to the I think they need the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that now if just do that for initially. If I is smaller than we need to store that in a I think they need the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that now if just do that for initially. If I is smaller than we need to store that in a I think they need the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that just do that for initially. If I is smaller than we need to store that in a I think they need the first element more than through first element. I think from now by this method we will try to find. Now we have find the smallest meaning that just do that for initially. If I is smaller than we need to store that in a I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. I think they need step first alone rather than through first element. I think by this method, now Mumbai just wanted to confirm here also the student came under the store that inside. deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid deep learning mostly more reacts to the environment and culture. I think the process alone does have an equal personality. I think technology is like the fundamentally rapid
J is equal to 0, I is equal to 0, 1, 2, 3, 4. J is equal to 1, I is equal to 1, 2, 3, 4. J is equal to 2, I is equal to 2, 3, 4. The smallest number is constant. The changes. The pattern J is equal to 0, I is equal to 0, 1, 2, 3, 4. J is equal to 1, I is equal to 1, 2, 3, 4. J is equal to 2, I is equal to 2, 3, 4. The smallest number is constant. Find the changes. The pattern J is equal to 0, I is equal to 0, 1, 2, 3, 4. J is equal to 1, I is equal to 1, 2, 3, 4. J is equal to 2, I is equal to 2, 3, 4. The smallest number is constant. Find the changes. The pattern J is equal to 0, I is equal to 0, 1, 2, 3, 4. J is equal to 1, I is equal to 1, 2, 3, 4. J is equal to 2, I is equal to 2, 3, 4. The smallest number is constant. Find the changes. The pattern J is equal to 0, I is equal to 0, 1, 2, 3, 4. J is equal to 1, I is equal to 1, 2, 3, 4. J is equal to 2, I is equal to 2, 3, 4. The smallest number is constant. Find the changes. The pattern J is equal to 0, I is equal to 0, 1, 2, 3, 4. J is J is equal to 1 swap I is equal to 1 to 3. J is equal to 2 I is equal to 3. Now we want to find the logical changes.
Step 1 states get the minimum.
J is equal to 0
And
I
you
is
got the
equal to
minimum.
0 1 2 3. J is equal to 1 swap I is equal to 1 to 3. J is equal to 2 I is equal to 3. Now we want to find the logical changes.
Step 1 states get the minimum.
J is equal to 0
And
I
you
is
got the
equal to
minimum.
0 1 2 3. J is equal to 1 swap I is equal to 1 to 3. J is equal to 2 I is equal to 3. Now we want to find the logical.
ಬ್ರೇಕಿಂಗ್ ನ್ಯೂಸ್ ಇಂಡಿಯಾவோட biggest education platform ல நம்ம நெக்ஸ்ட் வேவ் இப்போ அவங்களோட மோஸ்ட் இன் டிமாண்ட் டெக் ப்ரோக்ராம் ஃப்ரீ ஆக்சஸ்.
So if you're looking out for a structured DS algo course smaller than array of whatever minimum index you're considering, one is 0 lesser than 30. It's very simple. Teen there. Swap it up, and then I go up array. So you have to dot till n. Is for the first time when the loop gets inside, this particular loop runs for n times. Exactly. Yes. Next time when it gets in, then this actually runs for one lesson. It runs from 1 to n minus 1. So can I say it runs for n minus 1? Next time when it gets in, it runs for one lesson. So it's like n minus 2. Next time when it gets in, it runs for one lesson. N minus 2. So on, it kind of runs for till last that we run for this is still here. That's for two times. So this is kind of if I just try to take it to some near formula stuff. Can I say it's something like 1 plus 2 plus 3 plus dot till n, which is nothing but the summation of the first n natural numbers, which is n into n plus 1 by 2. Can I say that? I can. So if I can say this, what is this? N square plus n by 2. Can I say this is how it looks like? And if you remember the time complexity, like, here, we ignore smaller things because n by 2 in comparison to n square is very small, and we ignore constant. Thereby I can say that the time complexity is near about big O of n square, and this is the best, this is the worst, and this is the average time complexity for this particular algorithm. So we can let's do it. 1324, is it okay? It is okay. 2446, is it okay? Yes. 4620, no. Swap 46 here, take 20 here. Let's swap it. 20, 46. Let's do the next. 46, 9. Are they? No. Take 9 here, take 46 here. 9, 46. Do you compare the last two? There's no point. Because 52 is already in the sorted packet. There's no need. So you only do it till here. Can I say now? In this particular array, 46 was the maximum, and it's at the last. So thereby, after two steps, the last two are in the correct orders. So step 1 is done. Step 2 is done. Let's do the step 3. So this is done. This is done. Let's do the step 3. Step 3 means this portion should be making sure that the maximum is over here. Let's do it. 1324. Are they? They are. 2420. No. Stop it. 2024. Next. 24/9. No, no. Tap it. Done. In this, 24 was the maximum. It's at the last. Step 3 done. Step 4. Can I say step 3 means last 3 elements done? This is left. 13, 20. Correct. 29. No. Swap. 9, 20. Can I say for this? 20 was the largest. And it's at the last. So thereby, post step 4. This is done. Next. Step 5. What is step 5? This. Let's do a comparison. No. Tap. 9, 13. So for this portion, 13 was the maximum. And it's at the last. So for this portion, 13 was the maximum. And it's at the last. So thereby, this portion is sorted. Post step 5. Do you need to do for a single element? You do not. Thereby, the entire array is sorted. If you see. So you have understood the algorithm. But now the key factor comes in, which is implementing this to code. Because that is where the key lies. Let's try to do that.
Okay. Let's do bubble sort. Okay. So first, bubble sort means given an array of integer called num, sort the array in non-decreasing manner using the bubble sort algorithm. Okay. So, I think we can take 5 minutes rest. ஓகே. இப்போ நம்ப ஆ என்ன பண்ணலாம்னா, bubble sort. So we can now try implementing the bubble sort. So in bubble sort, what we will do? So in bubble sort, we will take a pair of first two elements in an array. We will compare them and we will put the bigger element on the last and then smaller element on the first within that pair. And after that, we will compare the second and third element and we will do the same. And then third and fourth and fifth, fifth and sixth. So we will do this for the whole array. And after that, the largest element will stay at the last element of the array. And since it is the largest element and it is at the last index, we can ignore them. It is already sorted. And after that, we will compare in pairs and traverse through the rest of the array. And after that, the largest element within the sub part of the array will be at the second last index. And since these both last and second last index sorted, we can ignore them and we will compare the rest of the array. And we will do the same. And the largest element in that sub part of the array will keep on accumulating at the last index of that subpart. And that subpart will shrink and shrink. And at final, it will be just the first element. And when it comes to that, the whole array will be sorted. That is what we call bubble sort. So to implement that, what we have to do? Let's put timer, half an hour timer. Okay. Um, okay, now um, now what we have to do is what's that? Let's do. So first we need to compare. Let's say we have an array. So usually we will compare first and second and third and fourth. So that we can do with uh, hum. num of I if num of I is greater than num of I plus 1, num of temp, we can put some temp is equal to num of I plus 1, and I plus 1 is equal to I, and I is equal I plus 1, I is equal to temp. So like that we can replace them. Okay, that is one thing. And then we can increase that I. So that is one for loop. But after that, we need another for loop to decrease. Wait, this for loop is for one iteration. So we need nested for loop. Okay. How many variables we need? We need to see as we go. Okay, let's see. So first let's do the inner for loop, and then we will construct the outer for loop. Uh, so nums for let's get the j, because I we need it for the first for loop. For j is equal to 0, j less than, here here's the catch. Here we need to L, here we need to decrease it like I. Okay, this we will see later. And then j plus plus. And now uh, what we have to do? Wait a minute. Okay. Now let's compare first two element. So what we should do that if num greater than, if nums dot j is greater than nums j plus 1, then we need to swap them. So int temp is equal to nums j, and then nums j is equal to shoot nums j plus 1, and then nums j plus 1 is equal to sorry, nums j plus 1 is equal to temp. So is it correct? Okay. So we have interchanged the array. We are doing it till end. Mm, and now what should happen? That's it. We should traverse the folder. And now is the for int I equal to 0. I think what we can do is instead of doing this kind of thing, we can do I is equal to nums dot length, and then I is less than or equal to I is less than 1. Sorry, I is greater than 0. Okay, and then I minus minus, and then what we can do is we can just make it as I. Okay, okay. So I think now should it work? Hmm. Okay, let's try. Hmm. This is simpler than the previous one, I think. Okay, now what age test case we have? 74153. 74153. Okay. 0, 1, 2, 3, 4. So what we have to do is, what we are doing is we have I. For I, nums dot length. What is nums dot length? 1, 2, 3, 4, 5. 5 minus 1, 4. So I is equal to 4 first. Okay. I is greater than 0. Yes. Now j is equal to 0. And now if j is equal to 0 and j is less than I. Yeah. Now nums dot j. So nums 0th element 7 is greater than 4. Then what we have to do? Swap. So int temp is equal to what? Nums j. Temp is equal to nums j means 7. Temp is equal to 7. Nums j is equal to, so what the array will look like? 1, 2, 3, 4. So j, what is j? 0. First element will be 4. And then j is equal to temp. So it will be 7. Then 1, 5, 3. And then now j is equal to 1. So now j is equal to 1 means 4, 2. Sorry, this is okay. This is bullshit. And now 7, 1. So nums j 7, 1. 7 is greater than 1. So swap them. Okay, we don't need to care about temp now. They are swapping correctly. 4, 1, 7, 5, 3. And now j is equal to 2. What will happen? 7. Okay, again. 4, 1, 7, 5, 7, 3. And now j is equal to 3. Now 4, 1, 5, 3, 7. And j is equal to 3. Now I is equal to 4. So j should be less than I. So j will not become 4. So it will end. And now at I is equal to nums I will decrease. No. So I is equal to 3. J will be 0. Now what will happen? 4, 1. 4 is greater. So 1, 4, 5, 3, 7. And j is equal to 1. Now 1, 2. So 5 is greater. So it will stay the same. And then j is equal to 2. 5, 3, which is greater. 5 is greater. So 1, 4, 3, 5, 7. And now this is over. And I is equal to 2. J is equal to 0. 1 is not less than 4. 1 is not greater than 4. So it will stay the same. 1, 4, 3, 5, 7. And j is equal to 4, 3, which is greater. 4 is greater than 3. So we need to swap. 3, j will not become 2. Okay, let's try it. Oh, written. Written num. Test case passing. So within half an hour we completed bubble chart because bubble chart is like little bit simpler than other things I think. So you can see this. So this is what I have done. You can see at I have decreased I from first to the 16. As I is equal to 4, j is equal to 0, 1, 2, 3. At I is equal to 3, j is equal to 0, 1, 2. At I is equal to 3, sorry. At I is equal to 2, j is equal to 0, 1. And then at I is equal to 1, j is equal to 0 and everything is sorted. So you can see that we okay. Now bubble chart is over. Okay. Now let's see strivers how they have implemented the bubble chart.
What are we doing? Observations. 0, 1, 2, 3, 4, 5. We're going till if you can your and 0 to n minus 1, 0 to n minus 1 for the first time. Next time I is n minus 2, so 0 to n minus 2. Next time I is n minus 3, so 0 to n minus 3. It will have no one to compare with. So you actually go from here to here. Effect to what we will do. Then to that add the variable path. And the algorithm it's n plus n minus n. Can you so if I have to analyze the time complexity, can you analyze the time complexity for me for this particular case? It's quite similar to the selection sort. First time the algorithm kind of runs for n, then for n minus 1, then for n minus 2, then for n minus 3. So kind of it's similar to selection sort where I say it's n plus n minus 1 plus n minus 2 plus so on. The last is 2. It's something if you just add a 1 to it, it's similar to some of n natural numbers. So again, n into n plus 1 by 2, which is n squared by 2 plus n by 2 smaller constants dissolved. So the complexity is big O of n squared. Can it be optimized? That's my question. Yes, it can be. It can be optimized. This is the worst complexity. This is the worst complexity. And you can also call it as the average complexity. In most of the cases, this will be the common. Most of them. But imagine if I give you an array, which is something like 2, 3, 5, 15, and 20. If I give you an array, you'll be like, Trevor, this is sorted. Yeah, it is sorted. So do you run the loop for n squared? Do you go across every time? So
If you have 2 or more years of work experience in a consulting or MNC and you want to break into leadership roles in startups like Chief of Staff, EIR, or Founder Office,
what is the algorithm? Correct order? No swaps. Correct order? No swaps. Correct order? No swaps. correct order, no swap. Array dude, if everything is in the correct order and you're not performing a swap, if everything is in the correct order, what does it signify? The array is in the ascending order. If everything is in the correct order, the array is in the ascending order. So in the first check, you did not find a swap to be done because everything was in the correct order. So can I say if I do not do any swaps, if I do not do any swaps, that's when I stop. I do not perform. So it's kind of if no swaps done, I don't need to go. If on the first check no swap is done, I don't need to go for this. We stop. So the loop at the best case will run for big O of n if we do some optimizations. Let's go and do some optimization. So can I say if I say int did swap equal to 0 and over here if I just can say did swap equal to 1, which means if at any moment a swap happened, then it's okay. But if did swap at any time is there was no swap, then I break out. I will not go. If the array is sorted, it will just check for the first time and it will break post it. Right? This also runs. I'll prove you this one. I'll prove you this one. So I'll give you an example. 6, 5, 4, 3, 2, 1. Now what I'll do is I will just go ahead and print this how many times the array runs. Okay? And runs. And I'll just give it. And you can see how many times it runs. Terminal, and I'll go to run task. This is a descending order. And it runs for 5 ticks because the size is 6. It runs for 5. But if I just change it to something like 1, 2, 3, 4, 5, 6. And now see how many times the first falls. Let's see. Did it run? Just a minute. Swap. Okay. Let's run it. We run it. Did you see something? It never came to this because it did break over here. So it just ran for the first, did not swap and broke. So can I say the best time complexity will be nothing but big O of n. So the time complexity for the best of bubble shot is big O of n. This might be asked in an interview. You have to critically tell them the use case. You have to explain them in the dry run and tell them the worst and the average might be n square. But if the array is sorted, I will break out and I will end up getting a linear time complexity because the array is already sorted. So the bubble shot is done. Now let's move on to the next one, that is the insertion sort algorithm. So talking about insertion sort, you need to remember one thing. It always takes an element and places it in its correct position. Takes an element and places it in its correct position. Let's start. Yeah. The algorithm starts with looking at the first element as an array. And you will say that if this much is the array, the element 14 in a size 1 array is at the correct. If I look at this much and I ask you, is 9 at the correct position? You'll be like, no. 9 apparently should have been here and 14 should have been here. So this is what you do. You go to the next element and you ask on the left side where 9 should happen. And that is where you take. So you basically do it like this. 9, 14. Perfect. So then you go ahead to this one and you ask, is 15 at the correct position for a size? And you say. Then you go ahead and say, is 12 at the correct position for a size? And you say no. Apparently 12 should have been here, 14 should have been here, 15 should have been. So do you see a pattern? It's like 14 will come here and 15 will come. Everyone right shifts by 1 and 12 kind of goes in its correct orbit. So what you can do is You can take 12 and you can say, okay, 12, 15. 15 will come here, 12 will go here. Then you can say 12, 14. So you can 12 here and you can pass 14 here. You can go to the left and swap, swap, swap till it can be swapped. Till it can be swapped. So if you do like this, 12 goes here, it's like 12 and 15. Then 12, 14. So 12 goes here and 14 comes. So go to the left till it can be. Can 12 be swapped with 9? No, because that will distort the order. So it just goes till here. Simple.
Highest paid job in 2026 is not of product manager, is not of software developer, and is not of data analyst as well. The highest paid job.
So what will happen? It will be like 12, 14, 15. Perfect. Next is 6. If you look at 6, where ideally should be 6 in this array? It should be here, 9 should be here, 12 should be here, 14 should be here, 15 should be here. So can I do this? Can I take the 6 here? But I have to write shift every one by one. How do you do it? You take 6, you take 15. And swap. Next you take 6, 14. 14 comes here. And 6 goes here. Next you take 6, 12. 12 comes here. 6 goes here. Next you take 6 and 9. 6 goes here. 9 comes here. So if I have to do it, it's like 6, 15. Not in the correct order. Let's swap it. 15 comes here and 6 goes here. 14, 6, no. 6 comes here, 14 goes. 6, 12, no. 6 goes. Perfect. It's like 6, 9, 12, 14, 15. So if I have to write it by raising, it's like 6, 9, 12, 14, 15. Perfect. I just went down to the left till it could have been swap. Right? Next, 8. In this particular array, where does 8 will go? Where will 8 go? In this particular array, where will 8 go? Ask yourself. The answer to that is 8 will go here. So if 8 has to go here, 15 comes here, 8 because when you complete 8, 13 should have been here. Because you picked up every L and you did put it into its correct order. So how did it work? I picked up 1. First time I picked up the first guy. Next time I picked up the second. Next time the third. Next time the fourth. Next time the fifth. Next time the sixth. Next time the seventh. Picked up every guy. I'm running from index 0 to n minus 1. That's for sure. That's something for sure. I'm running from 0.
Okay. Now let's do insertion sort. Half-an-hour timer. Okay, so what is insertion sort? Insertion sort is like you will first consider first element as your you will first only consider the first element, and you will see which place is that element belongs if the array is sorted. If you have only one element and if you want to sort, there's nothing to sort. It is only that element. And then you will now go, so that is correct. So you will now include the second element. And now our array consists of first two elements. And if these two elements needs to be sorted, if this array needs to be sorted, are the elements are sorted correctly? Are the elements in their designated place? If yes, you will then include the other element, third element. Now your array consists of three elements, and you will check whether all the elements are at their designated place as if everything is sorted. If yes, you will include other element. If no, you will you included other element. No. So that element has the possibility of not being sorted. So you will swap them one at a time and reach its designated place. Okay, understand? So if our array has one element, then there is nothing to do. And you will include the other element. And if you see that element is, if it is sorted, is it at its designated place? No. If no means you will swap it till it reaches its place. And if you include another element, and if it is already in its sorted place, then it is fine. You will include another element. But if it's not at its sorted place, you will swap it one element at a time till it reaches its sorted position. Okay. So obviously this also needs two for loops, nested loops. So so we consider two for loops. Uh, so inside inner for loop, what you will do is so what will inner for loop have? The inner for loop will have I think for this case, we first need to do the outer for loop. Okay, let's see. Int I is equal to 0. Okay, so now our aim is to increase the size of the array, no? So I think we can make this as the size of the array. Okay. So inside we need to make another for loop. For int j equal to 0. Wait, this should not be equal to 0 first of all. I think, wait a minute. I think this should be equal to 0, yeah. But we need to check whether if the element is j is j is greater than something. Okay, let's say a. Okay, now j minus minus because we need to swap them. So for that, the index should decrease. Okay, so what we can do is, so at first we have, okay, first there is only one element, so there is no point in comparing them. So I think it's better to start with the first element instead of zeroth element because it's a waste of time. Now for first element, um, if that is sorted or not. Wait, if the element is not sorted, then it should go back, swap. So swap it. I think I need to write here. So there's element here. So let's say we are considering these two. Now we need to compare this and this. So what we have to do, okay, let's do this. Okay, so if nums j is less than nums j minus 1, then swap them. So int temp is equal to, and then and then and then okay. So now we swapped them. I think we can use while loop instead of a for loop, but we need a pointer. So okay, this is also found. Break. So what we did is j is equal to 1 and j is greater than 0. So what we are doing, we are comparing after and we are swapping. After it reaches its correct position, the that thing will not be greater than this. So we will break the for loop. So essentially, I think J should be equal to I, not 1. Okay. So, okay, let's write and see. Brain. So, what array do we have first? 74153. So, I will be 1 and nums dot length is 5. So, J is equal to 1. So, J will be 1. J is greater than 0. Now, if 1, 4 is less than 7, yes. So, temp is equal to 4. And then this will be 7. And then this will be 4. Okay, swapping is correct. Okay, so 4, J is equal to 1 now. So 1 place is 4 is less than this one. Yeah. So you will have array swapping. Hmm. So what will happen? This will swap 47153. And then afterwards, J will be 0. So J is greater than 0. So it will come out of the loop. And then I is equal to 2 and J is equal to 2. Now 2 is greater, this is lesser than this. Sorry. So, yeah. J is equal to 2. 2 is lesser than 1. 2 is lesser than 1? Yes. So we need to swap. And then J is equal to 1. And now J is equal to 1 is lesser than 4. Yeah. So we need to swap. So now, and now again j is equal to 2. Now 2 2 5 is lesser than 4. No. So break. Now 4. So whether whether 4 is 3 is lesser than 7? Yes. So we need to swap. So, so 3 is lesser than 5? Yeah, we need to swap. Now 2, 0, 1, 2. 3 is lesser than 4. Yeah, we need to swap. Now 1, 3, 4, 5. Now what? J is equal to 1. Okay. Now is 3 is lesser than 1? No. So break. And then I will try to go to 5, but array size is 5 and I can only be less than 5. So I is 4. So this is our final array. So I think this is correct. Let us check once. Oh shit, I didn't return. I didn't return anything. Okay, accepted. Okay, before half an hour we did it. Uh, so you can see my thing. There. So for now you can see that. Wait. So for I is equal to 1, j is equal to 1. And then we swapped 7 for 4. And then for I is equal to j can be, j will decrease from I to 1. So j is equal to 2, 1. And we had 2 swapping. And for I is equal to 3, for I is equal to 3, we have j is equal to 3. But for 2,